right, so we are streaming live, and then that way I could answer questions as they come along. I'll put those questions here. I like to be prepared next time, but it's okay. Completely fine. Zoom out. Live. View your channel. Live. All right, so, all right, here we go. Prepare next time, but it's okay. Completely fine. Zoom out. All right, so I'm muted. All right, so we got the chat here, and we are going good. So today I'm going to be going over Kubernetes and what that is. You know, it's like, what is I'm looking to learn? What is it that, just how it is that, what is Kubernetes, right? Like, I just wanted to kind of do like these live sessions of like coding and stuff like that. So I figured it'd be a fun little experiment. So let me send over this link to my bud so that he can watch. And it's just, this is the first iteration of many. So let's send this over to John. John is the guy he's a real technical guy. He doesn't really like to praise himself or kind of hear what's going on, but I'll plug him here. And I'll put it over here. I'll put my live Kubernetes session over here. We won't see much of it, but it's okay. So let me restart my capture on this. All right, so I'll be viewing from here on my Kubernetes, from the documentation of kubernetes.io, and then I'll be kind of hopping over into my notes. Let me refresh this screen, and jotting down what it is that Kubernetes is. And so as I learn, this is just intended to be educational. So as I learn, you learn with me, and sessions that make it fun. Let's see. Let me see if John hopped in. Let me hide this screen real quick. No, let's do this guy. Open my chat room, sounds good. Let's see, Dale. No, we don't want to share that screen. No, that's fine. Wait, no, we don't want to share that screen. We want to share. Yeah, we do want to share that screen. First start, no one's watching, no one cares, right? So it's completely fine. So let's watch that screen. Here we go. And this is John. Hop in. All right, let's see if John hops in. All right, so Kubernetes live session. Let's do it. Let's hide this. All right, so Kubernetes. What is Kubernetes? Kubernetes is a portable, extensible, open source platform for managing containerized workloads and services. So it's essentially just a way for you to kind of manage your containers and your application, right? That performs things such as scaling, maybe kind of rollouts, rollbacks, and things like that, right? So why you need Kubernetes? Kubernetes is, let's see. Oh, 2 watching now. Start a stream. Let's see who's watching. All right, that's good. Let's see, John's watching. Nice. John's our boy's in there. So here we go. We're live. Be sure to comment to ask questions. All right, and that's the thing. Like, I want us to be a fun learning experiment. So as we learn, oh sorry, I should have hit that screen. All right, so as we learn, let me refresh this. Refresh. All right, so as we learn, let's kind of make it fun. So overall, Kubernetes is a portable, extendable, open source platform, and so I've got a little background and understanding of it overall. But one of the questions is like, why would you opt for Kubernetes, right? And from my experience, or from what I'm seeing, is Kubernetes is something that allows you to be kind of a cloud provider what's that word I'm looking for? Where you're not really tied into a cloud provider, whether it's AWS, Google Platform, or even Microsoft Azure, right? So those that is done via it kind of gives you that ability, right? Whereas, say for instance, like ECS, it provides it's it allows you to kind of do these things called tasks and all of that. So from that perspective, that's why I think that Kubernetes is kind of the default. And so I kind of want to go into this session, what I've already kind of have or some of my notes, where Kubernetes versus ECS, where ECS can help with container monitoring services, right? To the service, whereas Kubernetes allows you to manage the process independent of cloud providers, right? And so let's kind of go over the components of Kubernetes, right? So let's see the objects in Kubernetes. Kubernetes components. Here we go. So here's a Kubernetes cluster, right, where it has a control plane, nodes, and these kind of things right here. So let's see the current components. A Kubernetes cluster consists of a control plane and one or more worker nodes, right? So the control plane consists of the kube API server. The etcd consists of a highly available key store. Kube scheduler, look for pods not yet bound to a node. So this, and pods, we'll go to that portion, but the kube control manager, API behavior, right? So, and then the cloud controller manager, which is kind of the same as the kube controller manager in regards to, but then it's more interfacing with your cloud provider. Node components, right? So run on every node. We have the kubelet, the kube proxy, optional, and the container runtime. Software responsible for are not sure what those are, right? But let's put this down and let's see what this is. So Kubernetes. So let's I'm gonna kind of mark these things down as I learn. Here, let's go to my notes. Here, let me see what we got here. All right, so let's go to my notes right here. Properties, go to my screen. I think these learning sessions will be really brutal, but then also from the standpoint, they're just not like, this feels like I would hate to watch one, but it's okay. It's okay. We're learning. I'm learning. And hopefully they turn into these things where we kind of talk and we can code together. Maybe I'll add you to I'm going to have a live session. And so we can have devs kind of code in the background. I think that'd be kind of a cool thing. So let's restart this capture. All right. So the components of so we have the Kubernetes cluster. And so the Kubernetes cluster consists of the control plane and nodes, right? So Kubernetes cluster, let's fix that right. And beneath it, we have control plane. So there, stop that. Control plane and nodes, right? Control plane, nodes. And so from a node to control plane components, we got the kube server. And let's, I'm just gonna take notes of this, so then that way, as I kind of learn it, I can always make it more in depth, but I don't want to they can just continue to improve. These are V1, so I'll always share the notes, and I'll probably just reiterate and record over these things. But kube controller manager, and let me see what we got here. Go to the screen right here. Start capture. Okay, so then now, what's happening? Everything's freezing. All right, so kube controller. Let's hide this screen. What's happening here? I'm frozen. Is this a good idea? Let's see. All right, so let's see what else we got. I don't know where my screen is. Oh, there it goes. Okay, so there we go. We're back live. All right, we're back, not frozen. All right, so next we have the Cube Controller Manager. Cube Controller Manager, and they put that in one word. And so I kind of want to understand what each component does. Cloud Controller Manager. And the node components are the kubelet. And let's see what all these things do, right? So let's go to kubelet. Right, kube proxy and container runtime. You don't always kind of spend time. Most people just kind of develop and like build stuff, and it's way more exciting. I'm not quite as good as this. So we got add-ons, DNS, web UI, container resource manager, and stuff like that. So I'll see what that gives us. Let's share the screen. All right, Cube APIs. Okay, so here's all the things too. So, oh, okay. So here's how everything, the cluster architecture. So the Cloud Controller Manager, the Cube API server, and so Cloud Controller Manager goes this way. The controller manager, the scheduler, and the nodes. So kubelet, so it can be, so nodes can have one to many pods. So I mean, they can have one or more pods, right? Kubernetes cluster consists of a control plane plus a set of worker machines called nodes that run containerized applications. So Kubernetes cluster consists of a control plane plus a set of worker machines. Okay, so the control plane. So, and what is that? I want to understand what that is, right? What is a control plane? Oh yeah, we already have that, right? So the worker nodes host the pods. So okay, here we go. The worker node or nodes host the pods that are components of the application workload, right? So worker nodes host the pods, right? Which makes sense, right? So the worker nodes are where like the application's kind of hosted in regards to like your container that has your software and it's running on the worker nodes. So that's good. Okay, so control plane. Let's write that down. I think that's important to know. Let's kind of go to these nodes. All right, so worker node. All right, so workers are nodes. So they host the pods that are components of the application, right? Of the application workload. That makes sense. So this is the meat and potatoes of our application, right? So, and then the control plane, and let's put the control plane on. And this manages the worker nodes and the pods in the cluster. And so the worker node hosts the pods, right? That are components. But then one thing is we know, and it's like a cheat, is that I know there's a worker node, but then there's also a master node, right? So I guess let's see. So from right now, I'm thinking is the managers the work. So manages the worker node and the pods in the cluster, right? So okay, so we're good. So here, all right. So wait, let's refresh this. Properties, research. All right, so this document outlines the various components you need to have a complete and working Kubernetes cluster. So it has node, and so it doesn't have anything. So the kubelet, where's that at? So the node, kubelet, kubeproxy, and the pods, right? Which I'm assuming is the pods. Okay, so let's see about this architecture. What's this? All right, this diagram figure 1 presents an example and a each node runs the kubeproxy component. You need the proxy component of each node to ensure the service API. Okay, we'll talk about that later. Control plane components. Okay, so the control plane components. We're at the control plane components, which are here. Let's go back to our doc. I should do half split screen, but it's okay. So control plane components make global decisions about the cluster, right? So for example, scheduling, as well as detecting and responding to cluster events. For example, starting up a new pod when a deployment's replicas field is unsatisfied. So let's kind of notate that. So global decision about the cluster. Decisions about the cluster. All right. Scheduling, as well as detecting and responding. So some of these things can be scheduling, detecting and responding to cluster events, detecting and responding. So the Kube API server, the API server, so that was one of the things. The Kube API server is a component of the Kubernetes control plane that exposes the Kubernetes API. The API server is the front end for the Kubernetes control plane. It's API. So the API server exposes the Kubernetes API, right? So the API server, all right, so let's see that. Kubernetes API server. And if I'm making mistakes, I can always, let me know. I can always get feedback on that. Let's see what we got here. The API server. Exposes the Kubernetes API, right? For the Kubernetes control plane, right? So API server is the front end. Ooh, that's sounds counterintuitive, right? For the Kubernetes control plane. The main implementation of a Kubernetes API server is Kube API server, right? Kube API server is designed to scale horizontally. That is, it scales by deploying more instances. You can run several instances of Kube API server and balance traffic between those instances. etcd, consistently and highly available key value stores such as Kubernetes backing store for all cluster data. So consistent and highly available key store used as a Kubernetes consistent and highly available key value store. Backing store for all cluster data. If your Kubernetes cluster uses etcd as its backing store, make sure you have a backup plan for the data. You can find in-depth information about etcd. Okay, so let's just see. We're just kind of, you won't spend too much time with, but it's okay. Consistent, high available key store. So consistent and highly available key store. This is key value store. All right, let's just say that. We don't need all that extra fluff. Right, so key value store used as Kubernetes backing store for all cluster data. Backing store for all cluster data. Wait, let me refresh this screen too. Wow, it's so weird. All right, so here goes. Here it is. Here's what I'm watching. For all cluster data. For all cluster data, okay. That's fine. And so, cube scheduler, control plane, component that watches for newly created page. Okay, so this is another thing that we need to kind of make sure to understand how that goes. So the cube scheduler watches for newly created pods. With no assigned node, and selects a node for them to run on, and selects a node for them to run on. Right? That's fine. What else? Include individual and collective resource requirements, hardware safety, software policy constraints, affinity, anti-affinity specifications, data locality, inter-workload interference, and deadlines. Cube controller manager. We're okay with that. This just has its own system for that. Control plane component that runs controller processes. So this runs controller processes, almost like the brain, it sounds like. Logically, each controller is a separate process, but to reduce complexity, they are compiled into a single binary and run in a single process. There are many different types of controllers. Some examples of them are the node controller, job controller, endpoint slice controller, and a service account controller. Node controller responsible for noticing and responding when nodes go down. Job controller watches for job objects that are completion. Endpoint slice controller populates endpoint slice objects to provide link to service pods. Okay, so the above is not an exhaustive list. Okay, so that's fine. Cloud controller manager that embeds cloud specific control logic, right? So the cloud controller manager lets you link your cluster into your cloud provider's API and separates out the components that interact with that cloud. And so that seems fine. I'm lagging on there. So a Kubernetes control plane component that embeds cloud specific control logic, right? So it just embeds. So let's put here, embeds cloud embeds cloud specific control logic. All right, we're good there. All right. So the cloud controller manager lets you link your cluster into your cloud provider API and separates out the components that act with your cluster, right? And so so it's just pretty much just a way to kind of like pull out the logic that's cloud specific. So then that way you can kind of like, I guess because a lot of the processes, like say for instance, if you're using like an Amazon ECS or something like that, like in depth and a lot of stuff that you need to kind of tie into it. Whereas with I'm assuming EKS would be the component that interfaces with your Kubernetes clusters, to where it's just like you just update the cloud controller manager and you can just like from component to component, you could, or from service provider to service provider, you could like get up and running relatively fast, right? Like spinning up using stuff like ECS is just like, it's pretty in depth. Like you gotta build tasks and it's a really complex process, and you're pretty much tied in once you kind of like lock into them, because now for you to pull it out and like if you're gonna change providers, it gets really in depth, and it's much more likely that you're gonna introduce big, right? The cloud provides node components. Okay, so let's go to the node components. We got the kubelet. So the kubelet, an agent that runs on each node in the cluster and makes sure that containers are running in a pod. So it takes a set of pod specs that are provided through various mechanisms and ensures that the containers described in those pod specs are running and healthy. The kubelet doesn't manage containers which were not created by Kubernetes, right? So it's running in each node in the closet. So node, I don't know why it has that too, kubelet. We already said that an agent that runs on each node in the cluster, right? We can say that runs on each node, and it just makes sure that container, so it's just kind of like making sure that your containers are running, right? Pod, that's fine. Kubelet proxy, kube proxy, sorry. Did I say kubelet? Oh, kube proxy. Is a network proxy that runs on each node in your cluster, implementing a part of the Kubernetes service concept. Kube proxy maintains network rules on nodes. These network rules allow network communication to your pods from network sessions inside or outside of your cluster. Kube proxy uses the operating system packet filtering layer if there is one and it's available. Otherwise, kube proxy forwards the traffic itself. If you use a network plugin that implements packet forwarding for service by itself, providing equivalent behavior kube proxy, then you don't need to run kube proxy on the nodes in your cluster. So a network proxy that runs on each node. So a network proxy. Maintains network rules on nodes. Good. All right. And then container runtime, if a fundamental component that empowers the life cycle of containers within Kubernetes environment. Kubernetes supports container runtime such as container cryo, and any other implementation of Kubernetes container runtime interface. So let's put the container runtime responsible. And let's see what those things are. Responsible. Let's put that out here. Responsible for managing the execution and lifecycle of containers within Kubernetes. All right. All right, so let's see what we got. All right, so web UI dashboard, add-ons, DNS. While other add-ons are not strictly required, all Kubernetes clusters should have cluster DNS. As many examples beyond it, cluster DNS is a DNS server. In addition to the other DNS server in your environments, which serves DNS records for Kubernetes services, container server, web UI dashboard. Dashboard is general purpose web UI used for Kubernetes clusters. Allows you to manage and so here's like an example of the where's the dashboard? Here's an example of the Kubernetes dashboard. Right, so this is running. I've already kind of run a few things, so I got my pods. So here's my test app and stuff like that. So that's pretty cool. So let's get back to that. So self-hosted cluster management tools, kube cops, kube spray. What's next? Nodes and their communication with the control panel. Ooh, I like that. Kubernetes controller, garbage collection, kube scheduler. Okay, so I just kind of node to control plane. Okay, so this is important to me between how the node and the controller. And so and then let's look at our notes between what we said between the other portion of stuff. Let's see, properties. So we had so we're trying to understand a node to control plane. And so the kube scheduler watches for newly created pods with no assigned and selects a node for them to run on with no assigned node and selects a node for them to run on. So the scheduler assigns nodes, assigns pods to nodes, control manager runs control process. Okay, let's just read it and stop trying to guess. All right, so Kubernetes has a hub and spoke API pattern. All API uses from nodes on the pods they run, right, or the pods they run, terminate the other control plane components are designed to expose remote services. The API server is configured to listen to remote connection on a secure HTTPS port, typically 443, with one or more forms of client authentication enabled. One or more forms of authorization should be enabled, especially if anonymous requests or service account tokens are allowed. Nodes should be provisioned with the public group certificate from the cluster such that they can connect securely to pods that wish to connect to the API server can do so securely by leveraging a service account so that, all right, so what's happening? Okay, so this is the communication. Low in the weeds, there are two primary communication patterns from the control plane. The API server to the nodes. The first is from the API server to the kubelet process, which runs on each node in a cluster. From the control plane to the control plane. API server exposes the Kubernetes API. So there are two primary communication paths from the control plane, the API server to the nodes. The first is from the API server to the kubelet process. Okay, that's the node. Okay, so which runs on each node and the cluster. The second is from the API server to any node. Right, so API server to kubelet. So the kubelet is running on the node. So node consists of the kubelet, kube proxy, and the container runtime, right? So that's kind of what the kubelet node is. The kube API server runs on a control plane, the kube scheduler, and the kube control manager runs controller. There are the two ways. The first is the API server to the kubelet. So the API server. What is the API server? Is the kubelet the control plane is referred to as the API server? All right, so that's my first problem. Man, it's got to be the API server, right? Two paths. All right, I think that's it. So the two ways of communicating, right? Let me see how much time we're at. I'm gonna do like 25 minutes, 25 more minutes, maybe 20 more minutes, and then pick it up. This is a live learning session, and from there we'll kind of review it and revisit every night for 20 minutes. All right, so no control. Oh, what we got? The control plane host API. Okay, so the control plane hosts the API. All right, so the control plane hosts the API. All right, so the control plane hosts. Oh, so the control plane hosts the kube API server. Is not the API server. So what is the control? What is it saying with the control plane then? So it's saying the API. Okay, so API server to kubelet. The connection. Where is this coming from? So control plane host API server. Okay, so control plane, and is that the Kube API server? Okay, so Kubernetes has the API. Okay, so none of the other control plane components are designed to expose remote services. API servers configured to listen action from the API server to kubelet are used for fetching logs for pods, attaching usually through kubectl to running pods. kubectl, the kubectl kube controller. Where is the kube controller at? I don't see the kube. Oh, what? Where's the kubectl? What? Wait. What is happening here? Let's refresh it. I'm not seeing where the. Oh, usually the kubectl. All right, let's see what we got here. All right, so it is the API server. Right. All right. Right. It has all the way to cube. So you can see the control plane has all the config and state for your setup. All right, so it has all the control plane has all the config and state for your setup. All right, let's see what that is. Control plane to node. All right, so API server queue. Okay, let's see the control plane to node. Wait, so node. Okay, wait. Let's see what we're talking about. Okay, so wait, we have the Kubernetes has this API pattern. Okay, so the control plane components also communicate with the API server. So the control plane components communicate with the API server over the secure port. So the API server, by leveraging a service account so that Kubernetes will automatically inject things. Nodes should be provisioned with the public root. Kubernetes has a hub and spoke API pattern. All API users from nodes or pods they run on terminates at the API server. All right, so control plane to a node, API server. There are two primary. Okay, so let's do this. Two primary ways, two primary communication paths, two paths, two communication paths. There's from the control plane. Oh, so I'm thinking the API server control plane. I'm not understanding what that is. The API server. And so we're going to say the first is from the API server to kubelet process. The first is from the API server to the kubelet process, which runs on each node in the cluster. Which runs on each node in the cluster. The server is from the API server. So the first API server, okay, to the kubelet process, right? And we see that on the kubelet process, right? Kubelet process, which runs on each node. We don't need to write that anymore. So which runs on each node, right? So we already got that in the cluster. And the second is from the API server to any node. API server. So the API server to any node, pod, or service through the API server's proxy functionality. All right, API server to kubelet. That's where this guy is. All right, so we're at the API. The connections for pods, attaching to running pods. So kubelet connects to fetching logs for the pods, attaching it to kubectl to running pods, and providing the kubelet's port forwarding functionality. So let's see that. These are the three reasons. 3 reasons, fetching logs for pods, fetching logs for pods. I'm assuming it's fetching logs from the pods, but attaching to, right? And it says usually through kubectl to running pods, and providing the kubelet, providing the kubelets port forwarding functionality. I don't really care, to be honest. Like, I get it. It's not like I don't care, but it's like we're getting in the weeds a little bit from this, but it's okay. And then let me just see, API server node pod. The connection from the API server to a node pod or service default to plain HTTPS. Let me start this capture so you can see. Okay, SSH tunnels. I think we're good on that. What's next? Control plane. Read about the control plane components. Secure cluster. Learn about the Kubernetes API. Ooh, let's see. Kubernetes control plane components. I already read this, right? We already did that one. Let's go back to the. Let's see. So let's see what we have over here. Containers. Images, container environment, we don't care about that. Workloads, pods, workload API, services, load balancing and networking, storage configuration, config map secrets and all that. We're okay with that. Policy, scheduling, custom administration, tutorials, hello minikube, learn Kubernetes basics. Okay, so let's create a cluster. All right, so use minikube to, wait, let's see what we can do. So use minikube to create a cluster, deploy an app, create deployment, explore your app, expose your app publicly. All right, so let's do those things. Let's hop into it. I think we're experts. So let's just go the path they said. Use minikube to create a cluster. And so let me go to minikube. Let me show minikube. And I've already kind of downloaded minikube. So here's minikube. Minikube, get started. So I found my version, and it requires a VM, right? So a container, VM, whatever. So I used my Docker. I got Docker Desktop on my system. So I just used Docker Desktop. Let me find my, here, let me see. I'll pull up my container so I guess I can show my path or what I did. So these people can, if you want to follow along or do that as well, we can do that. Where is my, let's see. Okay, so, no. All right, so I did on this one. All right, so let me kill my component, and so kubectl. Where did I? All right, so here's kubectl. So to install minikube, I just did the brew install minikube. And here, let's write these steps down. So at least that way, as we, I put over here. So I'll write down my steps that we took. So it'll be really easy to kind of replace it. Kubernetes live session. So I'm writing all my notes here on this guy. So live session, running, getting started. Let's put it here, getting started. All right, so first step, brew, install minikube. Once I installed minikube, next step was I downloaded the kubectl, And the kubectl was necessary. So let's go to kubectl, kubectl, install subkubectl, kubectl, right here. So I had Apple Silicon, so I downloaded the versions. And so maybe I should put the place where I downloaded that to. I'm not gonna do that. I'm not gonna do that. You can find it. All right, so download kubectl. What's next? Then I ran minikube start, right? So let's go back to minikube start. Start my minikube. And then after minikube start, and so then let's come to my terminal and I'll show like where you would theoretically end up. Restart session. After this, so I can run minikube status here and it's right minikube dashboard. So once I get minikube status going, minikube dashboard, click minikube dashboard. And what minikube dashboard does, it shows all these kind of like my deployments and stuff. Like it shows you how to manage like it shows you all your pods and all that. So I'm gonna kill that. So then at least that way I could, and then I'm gonna do my, and I'm gonna cheat for my earlier kind of thing, but I'm gonna just get my pods. And so it's kubectl get pods, and that's weird because minikube. I'm trying to understand what minikube does, and it's worth the time, right? So kubectl is the cube controller, right? See what it is. So let's just understand what cube controller is. Learning environment. You learn Kubernetes. Use the tools to support a production environment. Download Kubernetes. Download install tools, including cubes. What is install tools? kubectl, minikube, right? So here's the thing. So even here on the Kubernetes, it has the thing. So kubectl, command line tool. So kubectl is a command line tool. kubectl deploy actions. To deploy actions, inspect and manage cluster resources and view logs. For more information, operation kubectl documentation. So is the command line it allows you to run commands. So let's write this down. These are important. So kubectl tools. Let's write these important tools down. kubectl important tools. We're gonna be experts. We're gonna be experts in Kubernetes, and I'm gonna do like different things. Like next, I want to learn DynamoDB. So it's gonna be a whole bunch of sessions and stuff. Like if we get into like agentic AI and setting up different tools. So this is This is the first session of one of many, right? And it's gonna get better. Like I'm not gonna do live streaming of me. Is that right? Is that good? Of me just kind of like. Let's start with the important tools. Let's go over here. All right, so let's kind of show this screen as I go over my important tools. And so we're going to start with kubectl. And we're going to show that. All right, so kubectl is kubectl. Let's plug this notion in. The Kubernetes command line tool allows you to run commands against Kubernetes clusters. Okay, so that makes sense. So now I think we have that answer. Attaching usually through kubectl, right, to run pods, right? So that's what the API server to the kubelet process allows for attaching. So we do that through the kubectl against Kubernetes clusters, right? Against Kubernetes clusters. What else? Kubernetes clusters. Kind lets you run Kubernetes on your local computer. This tool requires that you have either Docker or Podman and stuff. Kind Minikube. So that's good. So let's just put them here because I think they'll be based off of whoever has, based off of each individual's kind of preference. Kind. And this is just kind of setting the foundation. As a tool, I'm gonna start running K8s. Let's you run K8s locally, right? Same for Minikube. Let's share my screen so you can see what I'm writing, so it's not just me. Minikube. Let's you run it locally. And Cube admin, I'm assuming. So I assume some type of admin. You can use Cube admin tool to create and manage Kubernetes clusters. It performs the actions necessary to get a minimum viable secure cluster running in a user-friendly way. Kubernetes clusters? What's the difference? Oh, it's running local. Okay. So I'm assuming it's not running local. View. What's QAdmin? Oh, it's on Kubernetes. The page shows it's on QAdmin. What is this saying? Okay, we're not gonna go through there. We'll cross that bridge when we need to. Nope. So QAdmin. So Atom or KubeAtom, whatever that is. All right, so allows you to create and manage K8 clusters. All right, so we're good. So now let's go back to getting started. Let's go to task tutorials. Hello, make it learn basics. Create a cluster. All right, so let's create a cluster. Use Minikube to create a cluster. All right, so that went by fast. We can do 20 more. All right. Okay, let's come back to this screen. All right, so no. All right, restart, refresh, restart capture. All right, so what happened there? All right, we're good. Oh, what happened? All right, so let's see what we got. Okay, so we've got using Minikube to create a cluster. Let's see what we got here. No VM. We got that. Okay, the Kubernetes API lets you query a minute. So the Kubernetes API, is that the same as the API server? I'm just obsessed with this thing where it says the API server. Fetching logs, API server to Kubernetes. The Kubernetes API lets you query and manipulate the state of objects in Kubernetes. The core Kubernetes control plane is the API server, and the HTTP. So the Kubernetes API lets you query and manipulate the state of objects in Kubernetes, right? So, okay, so that makes sense. So I'm assuming the control plane does this. Lets you query and manipulate the state of objects in Kubernetes, right? The core of Kubernetes control plane is the API server and HTTP API that exposes the different parts of your cluster, and external components all communicate with another through the API server. Okay. The core Kubernetes control plane is the API server. So it is the API server. So it's the API server, right? And the Kubernetes API lets you query and manipulate the state of objects in Kubernetes, for example, pod, namespace, config, mask. Also, which makes sense. So it's just managed through an API server. So all the actions that are done through to this, right? So which is means there's some type of security or some type of, and I think the Minikube kind of pulled that away. Obfuscated. I want to say obfuscate is the word. Let me look this word up real quick. That's important. Won't waste time, but obfuscate. Obfuscate. Definition. Means to deliver. Refers to clouding the facts. I don't like that one. What else? All right, so we're back here. All right, so okay, so I think so then also the Discovery API, Kubernetes publishes a list of all groups versions. All right. Open API interface. Okay. Open API v3. All right, so we're done with that. We're not doing that anymore. Let's come into the create a cluster. So learn what a Kubernetes cluster is. Learn what Minikube is before you begin to show command. So that's Kubernetes highly valued cluster. No VM. So wait, I was there. Let's go back to it. Oh, that's it. Tutorial. Hello Minikube. Create cluster. Deploy an app. All right. So here we go. Learn about Kubernetes cluster and create a simpler cluster using Minikube. Alright. We got that. API resource. We're not doing that. Alright, so create a cluster. And let me just see what I did, how you create a cluster, because I don't want to create deployment. Cluster diagram, the control plane is responsible for managing the cluster. What's next? All right, so we got the node as a VM or physical computer control plane. Responsible for managing the cluster. All right, so I think this is the Hello Minikube tutorial. Create a cluster. Okay, so here we go. So to create a cluster, step 1. So create a Minikube cluster. Let's take these steps. Oh, Minikube start. I wrote that. Yeah. Then we did. So I did Minikube start, and so I got my cluster going. So I did that. So if you haven't done that, you can go ahead and do that. Minikube start. And then next we just check the Minikube status. Let's come to my cluster. Let's go back to my main screen, right? Restart screen, restart capture. And then it started up the cluster, and then Minikube status, which is the second request thing they said, and there's what it says, a cluster, right? So we did those, and then here's the kind of the components, right? So once you have your cluster started by the start, and then Minikube status to see it, to verify it's running. Now let's open a dashboard. Minikube dashboard. Let's do Minikube dashboard. Oh, and let me just say we've done that too. So then Minikube dashboard, Minikube start, Minikube status, and let me notate what we're doing here. And then Minikube dashboard to see the status of your dashboard. Now, the next thing is one of the things that we have to understand is that when you're creating a deployment, you have to do it with the image that is like in like Docker Hub, right? So if we go to my Docker Hub, is it Docker Hub? Docker Container Hub, Docker Hub. Oh yeah, here it is. So here's my Docker Hub, right? And I've got, and so I spun up this Docker image through the commands of where you just, and those are Docker commands, essentially where you just, you build an image, right? So, and let's see if I still have these Docker build. I'll just redo, I'll do another one. So Docker tag, here wait, let me share this, okay, so let's here so we can see what's getting communicated to us. All right, let's see what we say. Right. Or yeah, of course. Or any comparable container registry, right? So it'd be on AWS or something like that. So um, I just used. So for me, I just pulled into. Let's see. Let's go into an application. I'm doing these. Let's do cube action setup. CD cube action, and this is like a um, it's not much. It's a Node.js application, just to kind of show how like how to deploy an application. So it's just a Node server and package.json. Here's the components. It's a guy that I saw it from the repo, from a Udemy course I took. And pretty much here's the Docker file where we're just kind of pulling a node. Yeah, the work directory, copy package.json, run npm install, copy that context, expose port 8080, and then spin up the application, right? And so let me just kind of just do and I'll spin it up and I'll have it be a different application. So I'll just Docker build. Is that how does it look? Docker build. Docker build. Sorry. Docker build. Period. I think. Right. Yeah, that's it. So I built my Docker container. Oh, wait, how do I? Let's look at Docker. Let's look at Docker. Let's see. Docker build. I'm sorry. Let me share my screen. Restart screen. So capture. So Docker build, and we're gonna give it a tag too. So, will you build your Docker build is one of the engines packaging your software. Docker build CLI. I see the CLI. Docker build. Docker build. Core concepts. Build checks. Building. Where's the commands? Guys, Docker build. Let's see, because I want to build it and then I want to tag it. Docker tag. Okay, so I'm just gonna build and then I'm gonna tag that. I think that's fine. I build that and then let's Docker tag. So I built it right with Docker build period. So let's write that down. Build container. Docker build period, and then let's do a Docker tag. And so we're gonna Docker tag with. I have a repo, and so I'll create a new repo. I'll create a new repo. Let's create a new repo on my Kubernetes. Let's go to repos, repository, and then live. Ooh, okay, here we go. Let's go create repository, and we're gonna call this Kubernetes K8 live, short description, a test repo for I'll take too much time for this to test during a tutorial. Oh, you reach a private repository limit. Let's go to a repository. So let's delete a repository. Ooh, how many do I get? Well, we won't be. Let's see. Can I delete this? Yeah, I don't know why I did this, but what I did with this. But can you delete repos? Storage, collaborations, repo. Go to Docker build. Settings. Make public. Oh, I don't want to be private. I don't want to be public. It's like let's delete this repository. It's probably something really cool too. Let's see what it is. Let's see what it is. I'm not gonna delete it. Let's run it. I don't care what it is. Let's run it. It could be some proprietary information. We're deployed. I created it a year ago. It's good. This is a good test, right? So we pretend like that step we did with the Docker build. And let's just run another Docker tag. All right, so let's do this Docker tag. Let's put this Docker tag. It's little I test. All right, so let's Docker tag, and then let's call it. All right, I'm just calling it case live. Wait, no, because now I'm deploying to that environment. I don't want to tag. I don't want to tag, so I'm already live. So I want to, and I've already pushed. Wait. Yeah, so I already got that. Scale, Kubernetes create deployment. Let's do this. I'm gonna create deployment. There's my repo, right? And then let's do create deployment. Let's create deployment from that guy. So let's go. So the command to create a deployment, right? And the kubectl is the one that creates the deployments. Do we want to refresh on what kubectl create deployment does? 1 sec. And so we're going to deployment is create deployment. Image equals Lolo25. I'm live right now on YouTube. John's watching. He's watching. That's good and stuff. Yeah. Yeah. He's here coding with me. Image equals this. Lolo25. I test. So let's create this deployment. Is that right? And I know something's gonna happen. Create deployment image. Do I have image equals that? Create deployment. Let's do it. Let's do it. Wait, what? What happened there? kubectl create deployment. kubectl create deployment dash image. Oh, dash image. Sorry. Dash image equals Lolo25 I test. kubectl. Wait, what am I doing here? kubectl create deployment. Create deployment image equals create deployment. Dash image equals Lolo25. Is that right? Is that my kubectl create deployment I test. Something's wrong here. Now I'm getting concerned. kubectl create deployment. Create deployment dash image. Lolo25. That's my image name, right? Pause I test. Tags. Wait, is there nothing here? Let's see. Oh, what is here? What am I doing? Cube tester app. Oh, I see. Here's a tag. So is there nothing here? Here's the repository. Here's the tags. Right. I don't have anything here. There's nothing here. Right. That's what's happening here. No, we're not doing that. We're doing repository. Oh, test. I don't have anything here. Tags, image management. Tags. There's nothing here. That's the problem. There's nothing here. All right, let's just make sure. Repository. Yeah, there's nothing here. Cube tester app. Image management. Yep. Here's the image. Yeah, so there's nothing here. So let's push. I'll push to it then. Perfect. I don't need to push. I don't need to. Dang. What the heck? I'm probably gonna. All right, that's fine. So let's just push this image. So let's test, and then let's go Docker push. Docker push. All right, so let's put this low out of test. Docker push. Did I tag? I didn't tag it yet. All right, so let's tag first. Oh, all right, so let's do this Docker tag. All right, perfect. So Docker tag, Lolo25. Oh no. And let's call it K8 live, K8 live. Right. No such thing K8 live. What happened? No such image. So Docker, let's see Docker. Dang! Oh, all right. It's fine. This is fine. We're figuring this out together. So guides, let's see tag. Wow. Tags. Docker guides, Docker tag. Oh, I don't want to like read through the command. Just be quiet. Docker tag. All right, so Docker image tag. Docker tag. Oh, I see. Wait. Oh, do I have to not build? What am I doing? Docker image build. Let's see what Docker build does. Oh, Docker build period. And so, Docker build. Build kind of like builder. Docker build. So what happens when I build? Why is it saying? Oh, Docker build right here. Here we go. So this guy. Docker build. Docker build. Docker build. I'm live. Oh my gosh. Yeah. Hey, I'm live. This is live. This is going all over the internet. All right. Okay. How's your day? You had a good day? You going to bed right now? Yeah. All right. Love you. All right. So, Docker build. Another child drinking tea. Just this is serious. All right. I don't know how I got lost. How I'm not. So when I Docker built, I built my Docker container, right? I built it. I'm gonna like 3 more minutes. I'm gonna stop after 3 minutes. I'm gonna only stream for 3 more minutes. I'm not sure what happened. I Docker built. What does Docker build do? I'm not gonna ask GPT. I'm not gonna be that build. What does that do? So I build a context. Let's just go back and see what I did before. So I did Docker build. Docker deployment. Oh wait, let's refresh, restart the screen. Properties, restart caption. Restart. All right, so Docker build. So wait, I did a Docker build. This is too much. It's too much. Create deployment, test app. I created a deployment, but I did the Docker build. Or maybe it's in my other container. Until I did a Docker build. No UV log. These are other org, software, cloud, expose deployment. Docker build. I'm not understanding. I'm not understanding what my Docker build. It's okay. We're gonna power through it. We're gonna go 5 more minutes. Docker build. No, this is okay. All right, wait. I've been to Docker file. Oh, this old Docker build. Wait, why is that not happening? Let's do this. Oh wait, I'm in the wrong. I'm not in that. Why am I doing a Docker build? What is this? Let's that. Wait, so I did a Docker build. Docker build. Docker build. And then now I need to do a Docker tag. No such image. Oh, I need to do a Docker push. I need a Docker push. Let's do a Docker push first. Sorry, I did Docker push. Let's do Docker. Did I get him back wrong? Lolo 25. Lolo 25 / I2I test. Whatever. Image design is over the tag. Oh, let's go Docker Docker I image ls. Let's see what that does. Cube tester. That's my image. I created this 27 hours ago. Cube tester? No, I didn't. I don't know what the hell is happening. Docker build. Let's just talk. Let's Docker push, Docker build. Why is that not happening? So Docker build. So Docker build, the Docker command starts to build using build kit. Examples. Maybe Docker build tag. I'm not. This is legacy. Docker build x tag. Is this saying this is legacy Docker build x Docker build x Docker build Docker tag. All right. I have to. I gotta come up the steps offline. Once I do that, then I'll start back, or I'll do it again tomorrow. That's enough for today. That's enough. All right. See you guys tomorrow. Good night. And tomorrow I'll come back and finish up this, second part. But I'll review some of this offline and then kind of come back.